Welcome to Yaka Digital Network. The standard logistical pathway from coastal ports involves long lines of heavy trucks gridlocked on narrow roads. Now look at Rotterdam. You see automated gantry cranes and driverless vehicles moving thousands of containers continuously without a single traffic jam. How a port organizes its physical space at the water's edge dictates the economic health and trade efficiency of the entire inland region that relies on it. This map highlights Rotterdam's position. It holds the geographic title of a gateway port, meaning it serves as the primary entry point for goods meant for an entire continent. The inland area served by this port is called its hinterland. Notice how the massive industrial centers in central Germany depend entirely on Rotterdam to process and forward their essential raw materials and exports. Rotterdam manages these massive trade volumes using specific logistical pillars. The first is inland water transport. Specially designed river barges move heavy shipping containers directly up the Rhine River. This comparison graphic illustrates the efficiency of water transport. One single river barge carries the exact same cargo load as dozens of standard cargo trucks. Relying on barges saves immense amounts of fuel and removes destructive friction from the highway system. The second pillar is rail integration. Rotterdam utilizes dedicated freight-only rail networks, like the Betour route, ensuring that heavy industrial cargo never has to mix with passenger traffic or city commuters. Deep-water docks are useless for global trade if you lack the high-capacity, dedicated inland connections required to constantly drain those imported goods away from the coast. As any port expands, it naturally collides with the surrounding urban population. Heavy industrial processing facilities end up fighting for the exact same physical space as residential neighborhoods, which creates severe congestion and pollution. This timeline map shows Rotterdam's structural solution. Over decades, the city physically migrated its heaviest industrial zones, specifically the oil refineries and chemical plants, away from the residential center, pushing them outward toward the sea. Pushing the industrial port seaward freed up the old downtown docks. The city then reclaimed these waterfront areas, transforming them into high-density housing, office spaces, and tourism districts. To manage a megaport, civic planners must deliberately separate the industrial processing zone from the urban waterfront to protect the city's overall livability. Looking at East Africa, landlocked Uganda acts as the dependent hinterland, relying on coastal gateway ports like Mombasa. This table highlights the infrastructural gap. Rotterdam uses dense canals and rail, while East Africa remains heavily dependent on road transport and manual systems. Let's test your understanding. If you were designing a brand new East African port city today, where exactly would you zone the heavy oil refineries to prevent future traffic jams? Take a moment to apply the Rotterdam model. The correct approach is deliberate physical separation. For East African coastal cities to clear their urban congestion, they must transition from regional truck hubs into modernized gateways integrated directly with inland rail. These parallel supply chains illustrate Rotterdam's final advantage. It operates as a smart port. Digital sensors and AI track every container in real time. While traditional ports face severe delays from physical documents, digitalization removes these bottlenecks, allowing cargo to leave the port almost instantly. This final cheat sheet outlines your examination points.
Rotterdam thrives due to its strategic location at the mouth of the Rhine, its highly efficient rail and barge network, and its strict seaward zoning that keeps industry separated from urban life. For more geography lessons, exam practice, and full course material, visit yaka.cc.